All right, welcome back, you guys. We stopped right there. We were talking about how theta, the central angle being 2 pi, that is your radian measurement for 360 degrees, one full revolution. Theta is a pi, only pi, that's 180 degrees, that's a half revolution, okay? And theta being pi halves is a fourth of a revolution. So if you can kind of keep that in mind, let's talk about your quadrants. Those are some big radian measurements, but let me open up a new one here. So let's talk about your quadrants. Okay, if you rotate anywhere into quadrant 1, your theta is going to be between, it's going to be less than pi halves. Pi halves is like 90 degrees. It's going to be greater than 0. In fact, why don't we just put the degree measurements below that for that to kind of make sense for you. Quadrant 2, so if you take your if you rotate an angle into quadrant 2, okay, you've rotated somewhere between less than pi, less than 180 degrees, and greater than pi halves. So you've rotated more than 90 degrees, but less than 180 degrees, okay? That's how you want to think about that. Of course, if you've rotated your measurements, your terminal side ends up being in somewhere in quadrant 3, that means that central angle is going to be somewhere between 3 pi halves, so that's your 270 degrees. We can talk about how to get that. And of course, we know we're more than pi, don't we? We're greater than 180 degrees or less than 270 degrees. And finally, if we rotate positively into quadrant 4, our theta is going to be less than 2 pi, so it's going to be less than 1 full revolution, and yet greater than that 3 pi halves, in other words, that 270 degrees. Okay. Okay. Now let's talk about some conversion here. So you want to be able to you've dealt with your degrees so much here in your schooling that you probably want to be comfortable being able to say, okay, it's this much in degrees to make this sense for me. How do I convert that easily to radians? There's a conversion process there. Well, we say, you know what? I know I know that there are 2 pi radians for every 360 degrees. So we just talked about that, right? There are 2 pi radians for every 360 degrees. And you got your degrees here. Maybe I'll write that. Your degrees. So if you were to, reduce that, obviously you'd have pi. So you got a pi revolution, so pi radians for every 180 degrees, right? And that's what you want to use for your conversion. That's the easiest form there. So conversion from radian to degrees and degrees to radians. Okay, so let's write all these down. So number 1, to convert, let's go from degree to radians. From degrees to radians, you would go ahead and you'd multiply by that pi over 180. Multiply by pi over 180. Okay. Let's do that. Let's say we have, we talked about that 90 degrees, right? So we have that 90 degrees. Let's say we didn't know what the radian measurement is, right? And I say, well, I know that for every pi radians, I have 180 degrees. You see how your degrees cancel, if you will? Of course, 90 over 180, oops, pi halves. There's your pi halves. So 90 degrees is the exact same thing as pi halves radians, right? So again, to convert from a degree measurement to radians, you want to go ahead and multiply by pi over 180. Number 2, to convert from radians to degrees. Well, guess what? We're just going to multiply by 180 over pi, right? 180 over pi. Okay, so if you're, say we're taking, oh, I don't know, let's take, let me erase these real quick. Pi fourths. Let's say we had pi fourths, and we're like, where is pi fourths? How much do I rotate to draw that? Well, we're going to multiply that. Remember, this is pi radians, so you want to cancel your radians, if you will. You're going to say, well, I'm going to multiply by 180 degrees over pi radians, right? Radians cancel, even though, of course, it's unitless, but your pi's are canceling there. So you got 180 over 4. Well, that goes 45 times, right? So you got 45 degrees is the exact same thing as pi force radians. So you know you rotated pi force amount or 45 degrees. All right, sorry about that little interruption there. Had a student come by. We just talked about this conversion from radians to degrees and degrees to radians, correct? So we're converting, if you're going from degrees to radians, you want to multiply by pi over 180, and the other way around, radians to degrees, multiplied by 180 over pi. So let's go ahead and let's do a couple problems here on the full screen. Let's convert from, and let's go from degrees to radians, okay? Hey, so we got this, let's say we got 60 degrees, 60 degrees, okay? I want to go from degrees to radians, so what do we multiply by? Oh, we got pi radians. You need to write radians for every 180 degrees, so we multiply by that pi over 180, right? So we got pi thirds. Pi thirds. So if you were to rotate 60 degrees, you would say that is pi thirds amount. I just rotated pi thirds radians. That's my central angle there, or 60 degrees. Okay, let's do another one. How about, let's go with 320 degrees. 320 degrees. So again, let's multiply by pi over 180, right? 320 goes in 180. Well, they both go into 10, so you got 32. And both of those go into 2. 16 over 9. Looks like we got 16 pi ninths is the same thing as 320 degrees. So you're like, well, that's 180, that's 270 plus 50 more. That is 320 degrees, or 16 pi ninths. 16 pi over 9, that's how much we just rotated. Okay. One more. Just for kicks, because they're just so fun. How about negative 30 degrees? Negative 30 degrees. Okay. Again, pi over 180, right? Well, there goes. That's pi 6. 30 goes in 180 6 times. So you got pi 6th amount. Pi 6 radians is the same as, whoops, I forgot my negative. Sorry about that. Negative pi 6th is the same as negative 30 degrees. So if you were to rotate negative 30 degrees, just a little bit there, that is negative pi 6th amount. Okay, negative 30 degrees. All right, let's do some more here. Let me clear this. Or do some more. How about let's convert. Let's go the other way. Oops. Let's go from radians to degrees. Okay, probably kind of got this already, but let's say you got, oh, I don't know. Let's say you got pi thirds, I guess. We'll take pi thirds. So if you're taking pi thirds amount, you're going to multiply by 180 degrees over pi, because there's 180 degrees for every pi radians. Again, pi's cancel, left with 60 degrees. So pi thirds, if you've rotated pi thirds amount, you have rotated 60 degrees. Okay? Triangle. What if you just have three? Just three. If you've rotated 3 radians, you're trying to draw that in, you're like, oh boy, I don't know. I don't know. I do know that if I rotate, if you remember from the definition, theta equals s over r, and if these two are the same, s and r, if you've intercepted this circle, right, this amount, s, the arc length, is the exact same as your radius, right? Then your theta must be 1. Your theta must be 1. You remember that? So if you rotate to here, this is 1 radian. Okay? So to here is 1 radian. So about to here, so would be 2 radians. About there's 3 radians. Of course, we know a rotation to here is pi, right? Well, what is pi? That's 3.14, right? If you were to rotate to there. Okay, so 3 radians is a little bit less than a half a revolution if you're to look at that. Okay, and how do you convert that? Well, you multiply by 180 over pi, right? So 3 times 180 all divided by pi, and remember this is radians, right? That's radians. So you got, I don't know, 180 times 3, whatever that is, 540. 540 degrees, or I'm sorry, 540 divided by pi, which is, let me punch that in, 171.887 degrees. Okay, so we've rotated, let me draw this again, if I've rotated 3 radians, so right to there, I've rotated 3 radians, that's about, or that is 171.887. Of course, that keeps going, but we'll chop it off to the 1,000th place there. Okay, so that's 3 radians. You can see it's just a little bit less than 180 degrees. Okay, so you probably got kind of a feel for converting from radians to degrees. So let's get a new page here. All right, let's find a let's sketch and find a positive coterminal angle. If you have theta is 9 pi force. Let me write that. Let me cut this off and we'll get into the next video here.